This is the homework 2.3 on page 111. So we do numbers 1 through 8. So number 1, we want to take an x squared equation and stretch it by a factor of 2. So we have y is equal to 2x squared with a stretch. Number 2, the cubic function y equals x a third, and it's being shrunk or compressed by a factor of 1/2. So 1/2 x squared. Number 3, if it's reflected across the y-axis, remember the y-axis is when it's inside, and it's a square root function. Number 4, the cubed root of x reflected across the x-axis, and then the x-axis is when it's out in front. Number 5, absolute value. Okay, applying a stretch by a factor of 3, so y is equal to absolute value, stretched by a factor of 3 out front, and reflected across the x-axis. And the x-axis, remember, that's on the outside. Absolute value. Okay, vertical shrunk by applying a factor of 1/3, and across the y-axis. So in the y-axis, remember, that's where it's negative on the inside. Okay, the cubing function, so x to the third, shrunk by a factor of 0.25, which is the same as 1/4 either way. So you can put 0.25 out front, or 1/4, reflected across the y-axis. Okay, that means you got to put this negative on the inside. Okay, now I'm fine if you leave it like this, or if you work that out, negative to the third power just makes the whole thing negative as well. So both of those answers are okay. Number 8, square root function. Okay, shrunk or compressed by a factor of 0.2. So you got the 0.2 out front, reflected across the x-axis, negative out front, and you have your x there. Okay, so those are numbers 1 through 8. Okay, number 29, we have y equals x squared. Okay, so we have the x squared. It is being vertically shrunk by 1/2, so 1/2 out in front, and shifted 7 units down. So remember, that's -7 on the end. Okay, 31, we have the square root of x. And 3 units to the right, so that's going to be underneath here, so -3. Vertical stretch by a factor of 4.5, so 4.5 out front, and shifted 6 down, so -6 at the end there. Okay, 33. Okay, we have this original function, x squared, and we want to write the equation for this function right here. So, okay, so I like to do the up and down first. Okay, so this is being shifted down 2. So it's at -2 here, so we're going to have -2 on the end. And it's being shifted to the right 5. So it's going to be x minus 5 in there. We also know that instead of opening up, it's now opening down. So it's reflected across the x-axis. So we have the negative out front. Okay, 35. We want to draw a sketch of this. Okay, so it's +2 up 2, -3 means right 3, and it's a square root function. Okay, 37. We don't go anywhere right and left. The 2, okay, if you think about this one, the square root of 2, if you would work that out, would be 1.41, and the square root of x. It's still greater than 1, so it's a stretch, a vertical stretch. So it's going to be, if I stretch it out, it's going to bring it up a little higher. 39. absolute value of 2x. Once again, it doesn't move anywhere right, left, up, or down, but the 2 is a stretch there. I could get into a horizontal stretch or compress, but I'm not going to get into that, I think, this year. Number 41. Okay, another way to write that is negative square root of x plus 1. Okay, if you want to see it in the form that we usually do. So that plus 1 shifts it up 1. The negative is a reflection, so instead of opening like this, it'll open down like this. 43. Move this up so you can see it a little better. Okay, so we have, okay, so on the inside we have 1 minus x. So if I set this equal to 0, I'd have, if I add this over, I'd have x equals 1. So it's going to be right here at 1. And the negative will open it down. And then since the negative is on the inside, it's going to be reflected across the y-axis, so it's going to open down like this. 45. Okay, we have the negative here. All right, sorry, I'm back. I had somebody at the door. We're at 45, so negative in the inside. I'm going to distribute that negative through. So it'd be like the square root of negative x minus 1. So set this equal to 0, negative x minus 1, and you would get, add the 1 to the other side, and divide, you get x equals negative 1. So it actually moves left 1. And then the negative there with that x, if it's a negative on the inside, it's a reflection over your y-axis. Okay, 47. Okay, so x to the third is our parent function, and minus 1 actually moves it right 1. So the graph will look like this. Number 49, a negative x to the third. So the negative out in front reflects over the x-axis. So instead of looking like this, it will look like that. And 51. Okay, so 51a, here is our graph, and we want to draw this graph, so negative of the function. So if you remember the negative of the function, negative on the out front, shifts it across the x-axis. So each point would be reflected across the x-axis. So it looks something like this. Okay. I'm going to pause it and draw it again. Okay, here I drew it again, and you can notice in part B, the negative's on the inside, so when it's on the inside, it's a reflection over the y-axis. So this point here would become, and this point over here. This point here would become this point here, and this would go out this direction, and this part here would go out this direction. And that's reflection over the y-axis. Okay, so this part C is a little bit trickier. What we want to do is we want to take every output and multiply it by 2. Okay, so if this is at 4, 1, if I take that 1 and multiply it by 2, it'd be at 4, 2. If this is at 6, 3, the 3 is multiplied by 2 to give you 6, 6. Okay, so that would go up here. So you notice it's stretching it out more, right? The times 2 stretches it out more. And here, 2 times 1 would be 1 there. And 3, 2 becomes negative 3 times 2 gives 4. Okay, so you can see that it's stretching it out a bit more in part C. And then part D, what is f of 0? So if my x is a 0, my y here is a 1, so that point there is the point 0, 1. So f of 0 is equal to 1. Okay, number 57, we're given this graph here. So we're going to take our f of x and add 1 to it. So it basically just shifts everything up 1. So if we think about if we're going to find f of 2, okay, is right here. So we take that output, which is the f of x, right? It's our y, or output, or 0. Add 1 to it, shifts it then up 1 to 2, 1. And if I have this is my output. I'm adding 1 to it. I'm then at negative 1. If I'm at 2, and I add 1 to that output, and if I'm at 0 and add 1 to that output. So you can see everything just gets shifted up 1. Okay, with this one here. I'm going to label these points here real quick. Okay, so here it's asking us to take the output, do the negative of that output, and then subtract 1 from it. Okay, so here my output, let's go with this point here. My output's negative 2. The negative of that negative 2 makes it positive 2. And then minus 1, 2 minus 1 is 1. So this point would become the point 1, 1. Okay, so if we're at 2, I plug the 0 in, so negative of 0 is 0, minus 1 would be negative 1. Okay, so we have that line there. 0, 0 is still going to be it. Plug a 0 in there, negative 0 is 0, minus 1 would be negative 1. Okay, plug the 2 in. The negative of 2 is negative 2, minus 1 more is negative 3. And then the negative of 0 is 0, minus 1 would be negative 1. Okay, so that's what that graph would look like there. These get a little tougher here. Okay, this one's really tough. Okay, so when I plug in an x, like say, let's take 2, okay? Half of 2 would be 1, so now I have to find f of 1. And f of 1 is negative 2. So then I have to take 2 and multiply it by the negative 2 to give you negative 4. So at 2, I'd be down here at negative 4. Okay, let me go over that again. That was kind of confusing. So for this x of a 2, okay, so I'm going to still here at x. I just have to know where the point moves. My output is a 0, right? Okay, so f of, I'm looking for an x of 2, so I plug a 2 in here. Half of 2 is 1. Okay, so I want to find f of 1. F of 1 is negative 2. If I do 2 times that negative 2, it gives me negative 4. Okay, let's take another point here. Let's take this point. Okay, so if I'm going to do negative 2. Half of negative 2 is negative 1. So f of negative 1 is 2, and 2 times negative 2 gives you negative 4. Okay, so that point's there and that point's there. Let's take the point 0, 0. Okay, so 0, half of 0 is 0, and f of 0 is 0. 0 times 2 is still 0, so we're still going to be right there at 0, 0. Doesn't move anywhere up and down. Okay, let's take this one, x of 1. So half of 1 is a half. We can estimate what a half would be here. Okay, let's say it's at negative 1. Okay, so f of negative 1 is 2 times 2 is 4. So basically your graph looks like this when you go through that. That one's a very, very tough one, very confusing one. If you didn't get that, it's okay. Just kind of try and challenge yourself a little bit with that there. Okay, last two, number 89 and 90. Okay, 89, we're writing the equation for this. Okay. Okay, it's an absolute value, so we know it's going to have to be an absolute value equation. And the vertex is down 1, so minus 1, and left 2, so plus 2. And then it goes up 2 and over 1, so it's a stretch. If it would just be up 1 over 1, and that would just be a 1 there, but it's being stretched out a little bit. Number 90 is the last problem. Okay, so absolute value again. It's going up 2, so plus 2. It's going right 1, so minus 1 inside. And it goes down 1 over 2 is the slope. Down 1 over 2 is the slope. So it's a compress of 1/2. And since it's opening down instead of opening up, we have that negative.